speak with me today and my team. My name is John Clamett. I'm a master's student here, a research student at the University of Pittsburgh, and our team is specifically conducting research on counterfeit printed circuit board components,
Hmm.
specifically integrated circuits, and and we're currently trying to develop AI-driven methods to detect counterfeit ICs, essentially. So that's
Great.
kind of a background of what we do. My
Hmm.
focus specifically is I'm really looking in on the pin one indent defects. If you're familiar with that, I'm assuming I've read like a bunch of your articles that you published, so I'm
Sure.
assuming you're familiar with that. And we can go around. Why don't you, Dr. Mai and Ashish and everyone, do a brief introduction?
Yeah. Hi, my name is Maya Abdul Hakim. I'm Associate Professor of Electrical and Computer Engineering, and I'm working with the group. I'm a PI on the grant. This is really research funded by the Naval Nuclear Labs, and we're looking at hardware security for using artificial intelligence for now, but then later on we will incorporate other tools like side channel analysis and others. Um,
Hmm.
so yeah, I actually work on security broadly, but also more specifically cybersecurity of cyber physical systems. So this is
Hmm.
one project, but I also work on space systems and energy systems, and I'm interested in how can we make systems more resilient and secure, and reliable at the same time. So nice to
Great.
thank you for taking the time to meet with us.
Yeah. Started this business about 30 years ago. And at that time, there wasn't, what we were worried about was used parts, not counterfeit parts. So we had to do our inspections and everything just to make sure parts didn't have solder on the leads. And of course, when you get counterfeits, that's part of some of the things we're looking at too. Solder on the leads, and maybe they've been pulled and they're scratched and damaged. But eventually, we started to realize that some of these parts were being counterfeited, and we were wondering, why they look so different. Different parts were like, wow, it's the same lot code, but they've got different looking labels and pin one indicators that John's talking about. Um, and so, as it became more prevalent, there started to be some seminars and things, and um, I went to learn, but also I was early on in that and got very interested because, like you may have heard, I couldn't sleep at night knowing my customers might get counterfeits. And I felt like, especially the aerospace and medical industries that we were selling into, I was nervous about that. So I wanted to find out everything I could. And in that, then thankfully people recognized that we're a good company, but also asked me to speak at a bunch of different kind of counterfeit convention type things, and at the military conventions and things like that too. So I'd say it's been almost 20 years now that this has been a problem, and it is an evolving problem, but we still have mostly the same types of counterfeits that you're seeing out there. There are some more difficult ones to see now that are being manufactured as counterfeits. Those are the toughest ones because you can't really tell. The pin ones are going to be perfect because they haven't been altered. The parts haven't been sanded down or anything like that. So it's more difficult, but it's maybe not cost effective for these people to make these, and so they're just some of the time they're doing that, but it's more common still for them to try to alter older parts. So that's me.
Can I
So
ask
Joe,
how
yeah.
do you currently detect that? Do you use also tools of AI or the functioning? Um,
No AI yet. I mean, that's really early on. I would love to see that you guys find something so I don't have to have these quality control
mhm.
people full time. At a certain point during the shortage, I had like 10 people working, and it was hard to find good people. But it is hard, that if the hard part's going to be for AI is that you're going to have to stage them in the right place and get these pictures and images, and it takes time just to do that. But the people know what they're looking for,
Mm.
so it'll. I'm sure it will take over at some point, but it might be quite a few years. You guys probably at the forefront of that, so um, looking forward to seeing what you guys can discover. There has been, I wouldn't call it AI, but there's been a lot of other companies or projects, I should say, like yours, that were looking at surface textures and comparing them, and they haven't really come into the market yet. And it's maybe been 10 years since I started seeing those kinds of things, but there wasn't true AI at that point. So it would be more, I mean, it was some sort of artificial intelligence, but it was just a lot of comparisons of things. And it will be interesting to see how true AI could make a difference.
The other tool we're looking at also is whether infrared can help the imaging, because it can detect something under the surface that we can't see from the surface. So, but we haven't still done that, but it's part of what we wanted to do as well.
Yeah, that sounds interesting. Yeah, if you can get through, I didn't know infrared. I don't know how that works exactly, but if you can see layers, because there really shouldn't be layers on a component. It's primarily a plastic encapsulated thing, and the only thing that should be encapsulated in there is the frame with the leads and then the die. The rest should be a similar, should be just that plastic injection molding.
Okay, great. So I have a list of questions. I have about 13 questions to ask you. There are some of them are very similar, so you might knock one or two down. And of course, like you can answer them any way you choose. There's no right or wrong answer. So my first question, just to get started, is out of the surface defects, what are the most common types of physical defects do you see in counterfeit ICs?
Yeah, I would say you hit the nail on the head for one of them, is those indentations that are either the pin one, or oftentimes I think it's part of the plastic injection molding process where there's some other sort of kind of an indent on the part. So you're going to see a few things there. One is that they might be sanded down on some parts, and you might not even see one on some parts because they've been sanded down all the way. Two, they're in different areas of the part, so they're just different. They don't look the same as the other ones. And then three, you're going to oftentimes see dirt in those that has been left over from their process, because it's a dirty process trying to refurbish these parts, and a lot of times stuff gets left in there. Oh, and I guess there's a fourth as well, as when they resurface the parts with the paint to try to make them look fresh again, they will get paint in that, and it won't look. Those indents are usually smooth on the inside, and the other part of the plastic parts typically have a very kind of bumpy surface. So in the indents, if it's the same, it's oftentimes that texture is coming from paint instead of the actual plastic.
So are you saying that in a follow-up question, that the indent and the surface textures shouldn't be the same, or that if they are the same, it's a higher, it's more likely to be a counterfeit?
I would say it's a 95+% chance that there's something altered on the surface if the texture and the indents is the same as the part. And I should say that if it's a smooth surface on the part, which there are some parts that are smooth on the surface, and the indent's smooth, that's less likely that it's a problem, but that's not typical. Usually there is a bumpy surface on the parts.
Sorry, I'm writing down some notes. So
Yeah, sure.
So the typical thing is that bumpy surface, the surface are more bumpy and the indent is more smooth, right? So if you find something different, then that's kind of indication of there's some alteration.
That's right. Should be very clean indents. Shouldn't see. You can go onto our website and find some pictures there, but and I've sometimes half the indent has some paint in it,
Hmm.
but they should be super clean. And
Hey, sorry, I have an experiment running, so I have to hop off in like 2 minutes, okay? Just FYI.
no problem, no problem.
Yeah, sorry.
Thanks for stopping by, Ashish. Okay. My next question, which you kind of already, my next question is, when examining these ICs for physical defects, what type of microscope do you use like for the examination? Do you know like the specific like microscope, like how like high spec is it? I guess is the
Yeah, we have a few different microscopes. The general one is 70 times, maximum 70 times magnification. And there's some lower quality ones that you can use, but we've tended to like one that's called the Meiji, Meije, I think it is. It's a Japanese brand. Good quality, not too expensive. Then there are some, $50,000 microscopes out there that can really get even closer images. We also use another microscope to examine the dye. That we'll probably talk about that. You probably have a question about that somewhere in there. And that's going to be more like 300 to 500 times magnification. You need to see a lot smaller details on that.
So you mentioned that we can check the pictures online. Is there like under products or?
That would be, there's 3 sections on the website, on the homepage, and one says how to spot a counterfeit.
Okay.
I think it's the middle one, right when you land on the homepage.
The guaranteed quality, how to spot a fake one. Yeah.
Yes. Mm-hmm. And then on our blog and our YouTube page, we've got also some videos that show how to do all the different things.
Yeah, part of the thing we want to do, we actually want to, because we want to see if the AI will actually be useful. So we
Mm-hmm.
want to actually be able to do sanding and see if we can expose the circuit and then see if we can detect that. But if there are already some pictures for things that have been,
Mm-hmm.
The counterfeit parts, then we can use that as well.
I could get you some counterfeit parts too, potentially. So
Wow, that would be really helpful.
yeah, that would be very helpful. In
Yeah.
our research, specifically, it is very hard to find counterfeit parts. Uh,
mm-hmm.
we can only find quote unquote non-counterfeit parts.
Mm.
So
Yeah, we've
makes
helped
sense.
people with that before for their. We keep a lot of the parts because of the fact that we don't want them to get back out into the market. So when a vendor sends us counterfeit parts, we put them into a quarantine. And so we have a lot of parts. We could send you some
Yeah.
samples for
That
your
would be
use.
interesting. And do you have also pictures of those or just the ones online?
We have tons of pictures, so I could send you a big library of pictures too.
That would be really amazing. Thank you.
You're welcome.
And John, do you have any other questions?
Oh, I have questions for
Nothing more,
days.
at least.
I don't know how much time you have, Mr. Hammond, but let me know if there's any time constraints. I have about uh, uh, like 10 more questions. So
Sure.
depending
Sure.
on how fast we answer them, it's up to
Okay.
you. So my next question is, and we kind of already we're getting into this, but what methods are used to create counterfeit ICs? And I'm particularly interested in blacktopping. Do you know like the types of steps they take and like the material involved in that process?
Um, I don't know the process and the material. I've heard some different things. Uh, Keep in mind that one of the main ways that companies like ours do the detection method is to use acetone on the parts to see if it comes off. So they're trying to use materials that will withstand acetone, but I would say at least 50% of the time or more, they don't. And you can see when you use acetone on a cotton swab, you're going to see black onto the cotton swab. So, you know, acetone is basically just like nail polish remover, which is strong. I mean, it's a strong thing. It's got to take off nail polish. So it's strong stuff.
Right.
So that, I think primarily they're using a paint, but sometimes they'll use, I've been told they'll mix in some of the plastic from the shavings from the, I don't know how they do it exactly, but that was a story at one point. I don't know how true it is. But yeah, I think they're trying to find stuff that's really, you know, averse to acetone. Now, if we see a texture on there and we can't get any evidence with acetone, then we take a razor blade and we start scraping on it, and you can see it peeling off. And again, there's some pictures on the website that will show that, and also even on our videos to show the demonstration of how to do that. So, so that works. And then there's a third method, which I don't truly believe in that much, but there's a product called Dynasol 750. And it works, but it even works on some of the plastic and damages it. So it's like, oh, I don't know, but the scrape test it's very evident, because when you scrape it, it kind of peels off another layer. And so I just think the Dynasol, with all of the hassle of using it, the chemical nature of it, that's dangerous. And you have to use it in a fume hood. You have to heat it up. It's just not worth it. And I don't think it tells you much more. It might even cause confusion. So we don't recommend that, but it is in one of the standards, so we have to use it. For, you've probably heard of AS6081, which is an aerospace counterfeit standard, and also AS6171, which is another testing standard for counterfeit components.
Okay.
So
Great.
Yeah. You know, it's funny, I didn't answer your first question or your second question completely, because I just talked about the indents. So I don't know if you want me to continue on with that.
We can, you can continue. I mean, I kind of got carried away because that's kind of the part I'm working on the indents, but it would be very helpful to see what other types of defects you see most commonly out there. I think
I should mention,
Dr. Howe.
I don't want to skip over those. So, as we mentioned, used parts, oftentimes the leads they'll have solder on them, or they're retinned. When you retin a part, then you're going to cover up the ends. When they make the parts, the leads get cut at the end, and then you're going to see, it won't be just the silver metal on the outside. You'll see like the copper inside the lead. And so when you retin a part, because you're trying to cover something up usually, then you're going to see that copper ending. No, you're not going to see that copper ending, I'm sorry, because you've covered that up. And that's normal to have the copper at the end, because when they trim the leads and shape them for purposes of putting them on the board, then that will be visible. Again, you'll see pictures of that on the website. So those are, okay, the leads, the blacktopping we just kind of talked about. The sanding marks, okay, we didn't talk about sanding marks. So just today, actually, you know, we're not finding counterfeits quite as often these days, but just today we found some where the parts had these directional sanding marks. Even though the part was painted on top of, you could still see, you know, they were so deep that when the paint went on, you could still see these sanding marks underneath them. So that's another telltale sign. And then when you turn the part, you want to turn the part on its side. If it's blacktopped, a lot of times on the side, you'll see where the blacktopping stops, because they have to stop at a certain area, because otherwise they'd end up painting the leads, right? So they have to stop on the top. They could blacktop the bottoms too, but but they usually don't. But you'll see like a line, and it's almost like, the icing on a cake where it stops, like if you're getting a bundt cake or something like that, there's like a little line where it stops. And so you can kind of see that when you turn it on its side and focus in with a 40 times plus microscope.
So
The markings. If they're etched markings, which means they use the laser to etch them, sometimes they're using some older equipment and don't know how to use it as well as the actual manufacturers do. So they'll stop somewhere and it'll just really burn a deep hole in the process. So you'll see a letter, and then at the turning point, there'll be a deep hole. And then the shapes of the letters are sometimes really weird. They're not perfect, but when you don't look at it under a microscope, you don't see that. Same with logos. They get the logos really wrong oftentimes. On painted products, then sometimes you'll see overspray because they're not using the same quality of painting on those. And then you'll see things that are just not in the same area. They vary part per part. And so, that would be a definite AI thing that you could really tell, as you run it through a process where it's going through and checking all those differences. I mean, you're just going to be looking for differences on all those kinds of surface things. That'll be really good. I think that covers most of them. I'm sure there's more, but maybe we'll get to them as you ask your questions.
No, those are great. Like that's like super helpful. Um, and okay, so let me go through my questions. We kind of like answered a lot of my questions, just like us talking. So I'm gonna see
Good.
if like I'm just gonna choose the ones that are worth asking now.
these, I have just a follow-up question for the logos and the misspelling of things. Are they trying to hide the damage they've done, or are they trying to create something that looks legitimate?
The logos and the painting, no, they're not. They're trying to recreate what was
Recreate.
there. Oftentimes what they are dealing with is a customer needs a slightly different part.
Mhm.
It might be a little higher temperature rating or lower temperature rating, or a date code. They want a newer date code. So the customers want these things, and they have something that will work, but it's not exactly the same. So the customer can't use it. Different manufacturer, so then these counterfeiters, they're just trying to find a bunch of parts. Sometimes they're all from the same lot even, that are a different part, and then they want to put new labels on top of them that fit what the customers want,
Mm.
And so, yeah, they're trying to make it look exact, and the purpose of it isn't trying to cover up something in particular. They're actually the black covers it up, and then the markings are trying to give them a clear, incorrect
Mm.
thought about what the part actually is. So,
And they're in it just to sell those things, or?
yes, they want money. That's
Oh,
the main thing.
wow.
Okay. So in your experience, how often does the pin one indent provide a conclusive indication of a counterfeit IC compared to other visual indicators and just in general? So is there a tall, I know you mentioned like the paint within the indent and things like that. So is
Mhm.
that like a clear, definitive answer, like, oh, this is a counterfeit, or do you need to do more testing otherwise?
Um, I would say it's pretty prevalent, the indent. It's a good thing for you to go after. But if I were to rank the number one things to go after, I would say that's towards the top. But I would say number one, and this is where AI might be able to do is maybe as good as a human, I'm not sure. But, and they've tried to do this, as I was mentioning before, there were some other projects where they're trying to see the surface, what the surface looks like, a comparison between legitimate plastic encapsulated mold and one that's been sanded and painted. That's where we really see the difference. You know, we look at that surface texture and see what it looks like. And the problem with that is that they're also different. Like all the manufacturers, even from part to part within the same manufacturers, oftentimes the surface is slightly different, but it's the same in many ways. It's just a lot more jagged, I would say. Then when you paint over it, it kind of fills in some of the bumps and things. So our people are looking for a bit of more shine and smoothness, not flatness, but smoothed out, like kind of if you were to put water on top of, or a gelatin on top of sand or something, you know, it would kind of smooth out the sand, but it's still bumpy, but you would see a different surface than plain sand. So that's the other thing. And then, yeah, I would say for those kind of surface things, I would say those are the two big things, the indents and then the surface. Then after that, you know, you're looking at leads. I don't think you're getting to that point yet, but maybe that's another thing you'll get into someday, but looking at the leads to see if they're used and damaged and bent.
Yeah.
Was the indent actually designed for that to detect counterfeit, or just like
No, their placement.
to do in one, right? But I mean the difference in the texture.
Hold on, I've got a phone call I gotta get in here. Gone. Okay. No, they weren't designed for that. They're designed for pin one indicator, so it tells you how to put it on the board, what
Right.
direction.
Yeah. But I
But
mean
like I said,
it could be different texture than the out.
no, that's not why. I don't know exactly why. It's probably because the natural textures just kind of float on there, but when they do the pin one, they have to use some sort of a device to either to create it and or it's part of the injection molding process.
Mm.
So it's smooth because of that. It's not intentional for counterfeit purposes.
Right. Yeah. I read that like it's to indicate where the pin one, like where the lead is, so they can orientate the IC correctly on a PCB board. But my next question is, are there actually let's do this one. Beyond taking a step outside of visual, what other analytical techniques like X-raying, electrical tests does AERI use besides just the surface defects?
Mm-hmm. Well, let's see. I have to start with the most important ones probably. X-ray is probably number one to detect, because then you kind of look at the lot from the outside, then you can see what's on the inside, and sometimes we see different dye inside, dye sizes, and then and also the layout of where the leads connect and everything. It's they sometimes vary. They're called lead frames, and that's what connects the die to the leads. And then there's little wires from each point of the die and goes directly to the lead frame, and that lead that is supposed to be controlling that part of the part. So that's the number one thing. Then we use XRF also, which XRF detects what the metal's made out of. And there's specifications on the manufacturer's data sheets and websites, not necessarily specific to the data sheet sometimes, but to the package that tells you what the metal is supposed to be. And then XRF tells you exact percentages of what the metal is on the parts. And then we do a decapsulation to open up the part and see the actual die. And in there, then you can oftentimes see the part number on the die. Sometimes the part number is not on there. So it's like a die mask revisions and things like that. And so you don't know, and the manufacturers don't necessarily cooperate, especially with brokers, to give you that information. So it's sometimes difficult to know, but at least almost always you can find the brand of the part on there. So that's helpful. What else do we do? Well, we're looking at even the paperwork that we get from the companies, when our suppliers. A lot of times, we're looking for even misspellings on that. Sometimes they might put Rojas. I don't know if you know what that is, but it's some mostly lead-free, but also some other chemicals in the products that aren't supposed to be there based on which country or region you're sending to. They have prohibitions, so they'll change things on the paperwork for that, change the manufacturer. A lot of times, cheap passive manufacturers like capacitors and resistors, they'll make cheaper versions, and then they'll put like a brand name like AVX or Chemet or something on it, on the labels, to trick you. And you can't. There's no markings, not really extensive markings on those parts, so it's really hard to tell if they're different. And they perform similarly until they might get into a stress situation with higher heat or lower heat, things like that. So, and then electrical testing you mentioned, and we don't do that here, but we have it done often for our aerospace and medical customers. We'll send it out to electrical testing. It's a little too much for us to be able to have all of the different, parameters to be tested with all the machines we have here. You need a full-blown lab to do that, so we don't do that.
Yeah, great. My next question is, so what are the limitations of current detection methods in identifying counterfeit ICs? Is there any limitations that you guys or like what are some more of the advanced techniques that counterfeiters
Mhm.
will use that you were mentioning? You were mentioning how they now just manufacture these parts. It's just like really
Yeah,
hard to detect.
there's been some talk, and again, as one of those companies that research projects that was trying to get a foothold in this market, to actually get the manufacturers to put some special thing on the chip, in the chip, somewhere, that that would be kind of an identifier electrically or some other way, but it hasn't happened yet. You haven't seen manufacturers trying to do it because it's just so hard. They all use different fabs throughout the world. And trying to coordinate, I think, for them is really hard, to put little indicators on there that could be read later. And then it's a long-term game. It's like they don't want their products. They're hoping that the products just get sold and they get used right away, and they're not out there for 10 years and then come back into the market. So to put all that effort into, getting it into these parts to be sold in their normal supply chains, it's kind of a waste of time. But once it gets out there in the open market, then they could track it better. But they haven't done that yet. But there's been, like I said, there's been a couple of companies that have proposed that and really tried to work with manufacturers. And that would be an amazing thing to stop the counterfeiting if every part had some sort of a signature that could only be read by someone that had the right tools.
Um, okay, my next question is, how does the age of an IC, I guess for you're getting more like new like ICs like in packaging than coming in. But I was just wondering, do you know if the age of an IC affects the likelihood of it being a counterfeit or like a defect, if that makes sense? Because
Yeah, and we do get a lot
being
of we do get a use and buy a lot of old parts because of the market we're in. We sell to a lot of aerospace companies, and they're supporting planes even, for 20, 30 years. So it's not unheard of for us to be buying 20-year-old parts. Um, and they work fine typically. The problem that they have and that to be looking for also is the corrosion on the parts, on the leads, or even just oxidation that comes on the leads. And what happens as these parts get those types of anomalies over time, then they don't mount well to the boards because they don't the solder doesn't adhere to the leads well, and then you get problems with the boards later, or maybe even right away during the initial testing. So yeah, it's something to look at. That's what we look at all the time. We're looking at oxidation and corrosion, bent leads, like I mentioned, and the age. So that's where the age makes the biggest difference.
right. Okay.
So if you could
Um,
measure I heard you talking about measuring some thicknesses of, or not thicknesses, but under the surface. If you could measure an oxidation level somehow, it's not a counterfeit thing, but it is still would be valuable to in your research if you get to that point, to show age of parts potentially. It might not always indicate age. It could be storage, the way they were stored, but yeah.
right. Speaking of storage, we kind of mentioned this about the like how you keep the parts, but how do you like document and track the defects you do find on ICs? And do you maintain like do you maintain a database for analysis and like and you don't discard any of these ICs and whatnot?
Um, Eventually they get discarded, or we send them to people like you to do some research on. Um, but we do keep a full database of all the pictures of the parts. And we also, I would not say we track it well, but all of the data is in our database, but they're not tracked. It would be great, and you're giving me an idea here now, to actually give each anomaly a code per se, and really track it. And we've had 50 where we found with the indents and 170 with the texture. Like all those things would be kind of interesting to see, but we haven't done that. But again, we have all that data we have. Gosh, maybe you guys would be the ones I could give it all to, and then you could mark them all up and give me a graph of what we found most of if you were interested in that. But you'd have to read the raw data and then turn it into, actual codes and see what comes of that.
Yeah, as long as the correct thing is written somewhere so that we don't label them wrong.
Right, right. It would be
Right.
all like it would
Yes.
all be in like text form, It would say something to the effect of, corrosion on leads, sanded tops,
Hmm. Yeah.
paint in indent, and then you'd figure out certain words that fit in different ones, and maybe there's 10 categories
Hmm.
that they all fit into, but there might be 100 different ways that we write it out, and only 10 that you end up using.
Yeah. Well, yeah, that'd be actually very useful for us, for John's master's. He's looking into that specifically.
Okay.
Yeah, that is actually would be very helpful. So, yes. I have uh, a few more questions left, really only two. So one of my last questions is, are there any specific industries or applications that are more vulnerable to these counterfeit ICs? Um,
I would say yes, that, as you mentioned earlier, I'd probably say aerospace and defense is the most um, vulnerable for more than one reason. One is because they're old parts and you just can't get them anymore, a lot of the different parts. So if someone can make a part that doesn't exist anymore, it's pretty easy to sell it
Mm,
because they're the only one in town. So that's number one. But also, obviously, most vulnerable because of the application. If the landing gear doesn't go down, you've got a problem. You know, lives are at stake, and so that's the other reason that's so vulnerable.
right. And going back to the pin one indent, um, so is you, I know we kind of already talked about this topic, but so is there specific materials or residue that's commonly found within or around the pin one indent, or is it mostly just like the blacktop and the paint? Or I know you mentioned some dirt and stuff like that, or
Right? Yeah, you're going to see mostly you'll see paint or residue of some dirt. That's what you'll see mostly. Um, Actually, one of the other thing, I think you'll see it on the website too. There are sometimes companies that after they've messed up the pin ones, not companies, I should say counterfeiters, they'll etch, when they're etching the part number on there, they can also do etching to make a pin one indicator. And pin one indicators are, I guess they are etched sometimes, so that's fine. Um, you know, I mean, it's something we see, and you'll see on my website if an example of that, I believe.
yeah,
But yeah, sometimes
I
they are
think
etched when I think about it.
yeah, I think I read in the article that you published that uh there was counterfeiters they like I don't know how, but they etch like the indicator in when they after they're
Mhm.
done resurfacing the IC.
Right, right.
So, do you know how they do this process? Do they just like have like a, a Dremel and like just drill it in, or
I don't think so because I think that they need some pretty precise and small, able to do very small things. So I don't think they could do it by hand. I think they have to have some fairly sophisticated etching or painting tools.
right? So you don't see a lot of scratches on the pin one indicator itself. It's mostly just like the paint and like the sanding marks and stuff.
Right. Yeah, no, scratches aren't, I would say scratches is not a thing.
Okay, thank you. Um, that is all of my questions actually. You kind of answered a lot of them when we were just talking and about like the other questions in the beginning. So,
Great.
but yeah, I don't have any more questions for you. Dr. Mai, do you have any more questions?
No, thank you. I would just ask what's the best way to follow up, especially if you have like data to share, um, and maybe, the best contact information that we can uh, use.
Yeah, sure. Yeah, so John has my information.
Yeah, okay. That is good.
So John, just reach out to me after this call, not immediately, but when you get all your thoughts together, if you have, I've mentioned a few things how we can help you.
Yeah. No, thank you.
So please feel free to ask me to do those things that I've offered. And if there's anything else you can think of, I'm happy to help. So
Thank you so much. That has been very helpful. And
you're
we'll be
welcome.
in touch, hopefully.
Yeah.
Will not bother you. Thank you so much.
Yeah, thank you. This interview has been very helpful for our research and the research team. Uh,
Great.
truly
glad to help.
helpful.
All right.
So
Thank you.
All right. Well, best of luck to you guys. I know I keep on hearing about AI in all kinds of industries, and I didn't know when it was going to hit the counterfeit industry. So it'd be exciting if you guys got something going. That's great.
Hope so. We're hoping to do that.
yeah,
Hopefully we'll share whatever results
Yeah,
we
please.
have
Yeah.
for sure.
We can do some of the testing on any equipment you guys end up making. So
That's great. Yeah.
awesome.
Thank you so
All right.
much.
Thank
Thank
you.
you.
Thank you.
Bye, guys.
Okay, I will reach out to you, Mr. Hammond. Thank you.
Sounds good.